Hello, everyone, and welcome to the Boundary Systems HMX or Harness Manufacturing Extension webinar. I'm Sean Farringer, and I'll be your presenter today for this material. We're going to go ahead and discuss the Harness Manufacturing Extension and, why it's valuable to you and, what it can do and how it does what it does better than other workflows that may exist that don't utilize the Advanced Harness Manufacturing Extension. We'll have a short slide deck to discuss a little bit about boundary systems and myself, and then we'll kind of dive right into some presentation on the Creo side with respect to the Harness Manufacturing Extension. I would encourage everybody's on mute so that we can have a clean presentation with respect to audio. I would encourage everybody, however, to utilize the question functionality inside of GoToWebinar at any time during the presentation to answer questions, to ask questions. Towards the end of the presentation, I will cleave off some time and we'll go through any questions that are presented then or that accumulate during the course of the presentation and kind of speak to those things as necessary and as those questions come in. And we'll kind of wrap up not only with information about how to contact boundary systems and get more information about HMX, but also how to contact me and get more technical information if that's beneficial or desirable to you. So with that, let's go ahead and get started talking about the Harness Manufacturing Extension. So our webinar agenda, speaking, just broadly, is going to be to review and demonstrate the Harness Manufacturing Extension. We'll have this introduction and some topic overview. Theory being, we'll talk about harness documentation both with and without HMX. And our agenda will be, showing that in the software, the Q&A that I mentioned, and kind of wrap up on the end of our session. A little bit about me. My name, again, is Sean Farringer. My background has a lot to do with industrial machinery, plastic parts, and, CNC manufacturing, to speak broadly. I've been working with PTC stuff since 2001, coming into a bit of an anniversary here in this time frame, if you will. I've been a PTC certified trainer since 2007. My duties include training, consulting, and implementation, most typically within my focus areas of large assemblies, schematics, cabling, piping, and all things manufacturing. About boundary systems, we are the technology leader for all things PTC, partnered with, obviously, PTC, as that's a topic focus for us today. Other technology partners are boundary system, works with other technology partners, eTraj and other companies. It is one of the fastest, one of the 16 fastest private companies growing private companies in Cleveland. It's a part of the PDSVision group of global companies. As you can see on the slide here, Boundary Systems has essentially a global footprint. Capabilities are obviously product lifecycle management, PLM stuff, PDM stuff, product data management, CAD design and consulting, everything in the simulations space, and obviously product development itself. Boundary Systems has been awarded frequently for its efforts. Some of those awards and milestones, if you will, are listed on the slide now. Okay. Many of the technology partners that Boundary Systems works with are presented on this slide. Obviously, PTC at the top being our focus today, but other important, strong partners are listed on this slide to provide solutions for clients for the challenges that they face. Okay, so we're going to dive into our webinar demo now and have a look at the concepts and theories of all things HMX. Okay. When we get done, we'll wrap up and we'll have some Q&A and things to that effect, if you will. Oh, I'm sorry, I wanted to bump that slide and keep it. When we get done, we want to learn more about HMX. All of our presenters are certified trainers, and we can get down in the weeds with all of these topics. If you need to speak to something other than HMX, you're obviously encouraged to reach out to Boundary Systems. We can help you. Training is available both virtually due to continuing ongoing COVID implications, as well as in-center and on-site. Check the website for the full schedule of classes. Okay. So this would be my contact information, and we'll go ahead and put that back on the screen when we complete our demonstration. So with that, let's go ahead and start talking about harness manufacturing extension. Now, harness manufacturing, we don't really speak to the actual nuts and bolts of doing that in Creo. We speak to the theory of documenting it. So we have a simple, assembly on the screen that has some wires in it that we'll go ahead and use for the purpose of this discussion today. Now, arguably, everything would typically have more complexity than this, but it makes it very easy to take it apart into small component pieces and talk about things if we have a simple assembly for the purpose of things like webinars. So we have a simple assembly, just a couple of conductors present in the assembly, and we would subsequently complete this design in 3D as you see here, and then we would move to documenting it. Okay, what you see on the screen is representative of a theory of a cabling design that is in a pseudo, state of completion. So now it comes time to document these conductors and their connectors and share that information to a harness manufacturing or internally harness manufacturing group. Okay, arguably sometimes those things exist on site, and software like this would be utilized by the people making the harness. In many cases, in industrial machinery and other things, harnesses are built right on site. In many cases, they are, if you will, sourced to a vendor. And this documentation that we're going to create would be the stuff of providing that to your outside vendor or dealing with it internally in terms of manufacturing that, because we don't really obviously turn over this 3D Creo assembly to our vendors. We give them the nuts and bolts of what's necessary to understand and manufacture the harness. So with that being said, there are two possible pathways inside of Creo to document harnesses. There is the standard Creo harness documentation functionality, and there is the HMX functionality. In order to understand the value of HMX, you kind of should understand what it's like to do it without it. So we're going to do a little bit of that. Okay, we're going to go make and start the process of getting, we'll kind of walk through. I've kind of short-circuited steps of this, so we don't necessarily have to do all of the clicks. But we're going to walk through some steps here and get an idea of what documenting this very simple harness might look like to get going inside of Creo, absent the harness manufacturing, because this speaks very well to the concept of how strong is the harness manufacturing extension at helping me do things quickly. Okay, so with that being said, we have our harness, we have our stuff. Let's go ahead and begin the process of what we would do to document that absent the harness manufacturing extension. So inside of Creo, I'm going to say I want to make a manufacturing harness. Okay, so that's the first thing I would do here. And we'll give it a name. So I'm telling it I want to make this manufacturing harness. Now it's going to ask me what harness I want to use. I'm going to select the H1 PRT harness that is present on our screen. So we'll go ahead and open that and let it go and create the harness manufacturing design environment for me here. So now I have a harness manufacturing design environment that I will subsequently use to create the flat state and, assemble things, get everything kind of, put in order so that I can document this. The first step in harness manufacturing documentation is to create what we refer to as a nail board or a pin out or a flattened, if you will, drawing. We do not communicate these harnesses to manufacturing in typical case in 3D. This is done in a flattened 2D state, as you'll see here. So we would begin by flattening our harness here, if you will. So I'm going to select a start point on my harness, and I'm going to say I want to auto fan this harness out. Now it has subsequently flattened. I can minimize my sub window. So now it's subsequently assembled my connectors and flattened out my harness, okay? So we might take this opportunity to set up a view or something, and these views could be built in by default, if you will, to the templates and such that you might use for harness manufacturing, but it's going to be a lot easier if I have a view that I can keep referring to here for the rest of this. So we have this now. Now we might have a scenario where I obviously in this case need to redefine this component and change its orient angle and basically spin it around, and then I would continue to flatten, layout, move segments to get these things kind of put into a visual state that I might want to use for the harness documentation. Okay, so now I have my flat state, and I flattened this, I've assembled my connectors, and I have the flattened state, if you will, created of this model. So I'm going to go ahead and close this now, and we'll open up a pseudo completed version of that. So if I can find it. Oh, my DC light's not in memory. My apologies. Hold on. See my preview here. There we go. All right. So here we have our documentation of the harness, if you will. And we see that we would go and take this flattened state and we would start making pinout tables for the connectors themselves individually. We would create a BOM for these connectors, and we would basically do a run list, a wire run list, as you see here, that says, hey, these are the run lengths for these different conductors. They start and end on these pins in these contexts, or in this context, excuse me, of this documentation. So we would then create this drawing from our flattened harness manufacturing inside of Creo. And that's how we would subsequently document our harnesses if we were doing this in the context outside of HMX. Now, HMX is intended to, automate and expedite this process to the largest degree. We obviously now are maintaining not only this drawing, but the intermediate flattening assembly is also a document that we've created in this deliverable chain in order to document our harness, create these tables. Here's our BOM for this stuff, etc. So we have all this documentation done, and we are complete, and we did it with Core Creo. Now, what does this look like if we use HMX? So I'm going to go ahead and throw all that stuff away, and we're kind of going to come back here. Whoops, let me put this out of memory here. I'll kind of reopen that. All right, so here we are with our, our cable assembly again, our DC light assembly, if you will. We're going to go ahead and jump onto the applications tab and activate cabling. So this might be kind of where we are when we subsequently complete our cabling operation. Indeed, I am looking at the top level where in many cases we might actually be working with the cabling assembly itself as opposed to working with the top level. We might complete our work in a state like this where we only have the cabling assembly. The moral of the story is the parts of this on the Creo parametric side as it relates to HMX aren't terribly relevant. HMX can be, theoretically activated from the top level. HMX can be activated from this lower level of just working with the cabling assembly, if you will. So now in our applications tab, we have our cabling assembly. We have this thing here that we want to document. Let's take a look at what this process looks like with harness manufacturing and talk a little bit about harness manufacturing. So the HMX extension to duplicate the workflows that I just kind of did generically and very quickly on something arguably very simple. The HMX is an application that is accessed on our applications tab, and this is to generate a manufacturing drawing for a 3D harness. That is the specific workflow that HMX does. HMX is intended for the documentation part of the process. It is not intended for the theory of the creation part. The creation parts of the harness itself all still live and work just as we expect on the core Creo parametric side. That is all work done that's done on the cabling side, and regardless of the use of harness manufacturing, it doesn't really change much of anything on the cabling side. There are some very limited design influences, that best practices, if you will, that should be utilized with harness manufacturing in terms of how we do a couple of subtle things inside of cabling when we talk about the different ways we structure loops. That being said, all of that stuff is well documented in the help files, etc., about subtle little best practices that you might wish to use on the design side to help optimize things for the purpose of harness manufacturing. So now we'll go ahead and start this up. The Harness Manufacturing extension is a partnership with Virtual Interconnect Limited in terms of, where is the technology coming from? It's obviously supported by PTC, and you deal with PTC for questions, and your resellers like Boundary Systems for questions and working through and with anything in terms of harness manufacturing deployment. So when we activate harness manufacturing, it will present a list to us of all of the harnesses that are present in the active assembly file. Harness manufacturing, in sub-harnesses also. This example does not use sub-harnesses, but those would obviously be a part of what the HMX extension is ready to take care of. The HMX extension is fairly, full disclosure, it's a little explicit about units. Users do need to deploy a specific, if you are switching between English and metric units in your documentation frequently on the fly, you will have to do some switching for, a specific config.pro option that relates to the English metric context that Virtual Interconnect is paying, or if you will, HMX is paying attention to. So in my own work, if I'm demonstrating something in English units and I have to switch over and demonstrate something on a metric file, I simply have a config.pro that I load that only changes that one configuration option that makes the templating understand what I'm doing here. And to speak to that, we do have a template set available for us. Open an existing drawing template. There are default templates from the HMS application that you can utilize and manipulate. You can obviously, you obviously have a group of user templates available to you as well for these things. I'm not manipulating these templates at all for the purpose of this demonstration, but these things are available to you in so much as that the moral of the story being, at the end of the day, the templating, etc., is just what we would expect it to be in the background. It's PTC drawings. It can use formats and drawing culture theory that is already typical within your organization. It doesn't do anything special or different or otherwise there. These are just DRWs that, folks can interact with in the same way in the same way as they would for any other PTC drawing, if you will. We can do variable sheet sizes, if you will. We have some control over the margins and how we're handling scale factor if we wish to scale things. Whether we want to bend this to fit and whether we want to use cosmetics or not. Bending to fit is the theory of extremely large harnesses not fitting on the sheet size at a 1-to-1 scale that you're using. So what HMX will do is put legs or bend-offs inside of the harness flattening in order to scale fit that view to the sheet as applicable. So bend to fit is applicable with very long or large harnesses because they can be a little difficult to get, fitted down to the sheet, scaling implications come into play, et cetera. So that's kind of a little bit about what bend to fit does, is it speaks to automating, a lot of that stuff that, would be tedious in what you saw me doing absent HMX, where I was utilizing fan, layout, move, segment type functionality in order to kind of pretty everything up and make it like I want. So benefit and those types of things speak to a notable amount of that automation inside of HMX. You can customize tables to be included of your own and the columns therefore here, and then obviously save this stuff to be utilized with HMX. So we can say, hey, I want to create a wire list that includes name. I'll say wire name, and we're going to create that column, and we're going to have spool coming from PTC, and we will also have length. And lastly, we'll put our entry port on. And that actually creates two columns because it's ePort from and it's ePort to. Okay, so in the context of a from to, but we can customize these tables and we can save them and continue to reuse them and essentially deploy them on multiple HMX drawings. We can make that unique, if you will, only inside of this HMX output and configuration. If I would add this to HMX as it's applicable to this output, it would retain that for me. When we speak to the HMX configuration, it's very simple and easy to use, and it's intended to be so. Balloons, do you want to show them? Do you not? Reference designators for your connectors and such. Cone angle speaks to the fanning of things like balloons and stuff to that effect. When we start fanning out balloons and such on a degree of complexity, a parameter called cone angle is applicable to that to give us a distinction between how far the balloons are kind of incrementally spacing in a polar coordinate sense, if you will. Rotational coordinates, if you will. Do you want to output a log file that nobody probably ever reads anyway? No, you can, yes, no, things like that. Do you want to create the BOM file, the wireless file? Do you want to deal with unique file names? You can pad length, which is kind of neat. This is a unique functionality of HMX. I can't explicitly emulate this to my knowledge on the core Creo cabling documentation side. What this essentially does is either by percentage or, by percentage as they show here, says, hey, just inflate the lengths of this because we just really want to be sure there's enough. Now on the Creo side, it's, in all cases, it's taking accounting for the defined routing length and any internal strip length definition that is present for the connectors themselves. But this is a unique special thing that allows us to just inflate the overall result to just kind of be sure that when it is manufactured, that you will have maybe a little extra there just in case, to make certain that, things aren't pulled tight or something to that effect. It might be especially valuable in cases where we do know that we are designing to a very taut or close distance window between connectors, and the harness not have an excess routing or, if you will, in it that can accommodate, variations in length of any significance. We can obviously do fixed, as I mentioned here, fixed length and rounding to length. We can include the shields in the wire list. You can dimension to front of connector or not. And, that's, both how you look at the connector and the pins, et cetera. Some folks see that differently in terms of whether it's in-house manufacturing or typical external manufacturing, about which end of the connector we're looking at. Do we want to kind of centralize them, and do we want to display empty pins or not? So in this case, I'm just going to say, hey, no, I don't want to display empty pins when we do this. The info tab just gives you information about what version and build and license of HMX you are utilizing. There is governance with respect to HMX in terms of how much functionality is available to you, how many different objects you can flatten or have in the file set. There are restrictions on those things in terms of licensing, and what license you're using, be it light, standard, or advanced, is displayed there, and then some basic information about virtual interconnect and stuff to that effect. But again, clients using this functionality deal with PTC, not with virtual interconnect. This is just about them because there is some of their technology in the background working with this inside of Creo. So at this point, I've not only set all this stuff up, but I've explained it all. So we'll go ahead and flatten this harness now. So HMX does pretty much all the stuff that was annoying and somewhat tedious in the previous scenario. So now we find ourselves here, and I'm going to pull this stuff all up over here in a corner so we kind of look at more of it together. It's got some basic tables and stuff down here you see in the bottom from the template. Here's our cable assembly. I'll go ahead and drag this table up to the corner so we can view all of this together here. As again, I didn't make any changes to these templates. I'm just using their very large templates to do this. So here we see that it's produced a documented drawing with not only tabular information that would be relevant to harness manufacturing, but it's also produced relevant dimensional information about this harness and a bill of materials to include, all of the connectors and the layout and the documentation. My definitions of these tables, effectively just as they were in my manual documentation, are all present here. We see our run tables from, to, etc. We see our BOM table, if you will, item, quantity, part number, descriptions, etc. Our total lengths of those conductors are present here, etc. So, and then you see your connector, pinout definitions, if you will, also tabled over on the side. So you can see the PS1, LMP01, and SW01 connectors all documented here. It provides these things in, all of their templates just have these views and such by default. Obviously, you would, potentially manipulate those to accommodate your own standards and or company culture for this stuff. But HMX arguably got us to this same place right here a heck of a bunch quicker than I could get there doing that through, the standard cabling functionality, if you will, that is the way we have historically, and many folks typically do now, still document things. Arguably, I think it's pretty obvious on the face of it, the benefits of this functionality and the strength of it, just in that demonstration to say, hey, just on something this simple, you can see I had to go make another file. I would, bring the harness into, the harness would be in that file. I would flatten that harness. I would, deal with its connectors, reorienting the connectors, fanning out things as necessary to dictate something that looks nice. After doing that, then we would subsequently go into this mode. We would apply all these tables. We would create these views. We would make these dimensions. We would do that stuff, and then we would save it, and we would send it off to a harness manufacturer at that time. That's a lot compared to what HMX did very quickly just now. So HMX is a very, very powerful product for folks documenting harness designs. It's very quick and painless. And we have an update, we have a concurrent to date drawing right here in front of us, and this could subsequently be set to in-house or vendor-based manufacturing for this harness. And away we go. This is the scope of HMX. This is what it's intended to do, is optimize the creation of this drawing with the significance you just witnessed. The difference of me punching that stuff out manually and, again, doing this with HMX should be pretty obvious. If I make changes to the HMX configuration, I can change the output of these tables and the ballooning and, things to that effect. But it doesn't afford for an enormous amount of control because what's typical and necessary is all captured by the product. This information would be very necessary and typical in the sense of like everything I have on the screen right now to document this harness, and it's all automated by the HMX extension to get to this place. So with that, we have looked at documenting a harness, both, if you will, the standard way, and documenting a harness using the advanced harness manufacturing extension to get to the same place. With this, I'd like to open up for questions to the entire group. And I'll go ahead and put my contact information back on the screen. And while I'm taking questions, I will keep the contact information on the screen. Folks are encouraged to screenshot this as necessary, so that will be available to you later to reach out. And if we have questions, I will go ahead and minimize the contact information and speak to those questions inside of Creo. And again, don't hesitate to type any of the late joiners that might have missed my initial discussions about the webinar itself. Please type your questions into the question functionality inside of your GoToMeeting dashboard, and I'll speak to those questions right away. It's kind of our only practical way to handle questions in the context of so many participants and muting people individually, etc. So please. Questions about anything HMX, and we'll go ahead and speak to those. Don't hesitate to ask any questions. By all means, we are very much open for questions. Okay, awesome. We have a question. The question being, do I need to create the cables first in the cabling application using the cabling module, if you will, in order to use the HMX? And the answer to that question is yes. Irrespective of whether we would use the standard documentation workflows or we would use the HMX workflows, the concept of creating the routing and doing the cabling here inside of Creo cabling module that we're looking at right now, that is a standard part of the workflow in all cases, with or without HMX. Thank you for the question. Most appreciated. Okay, we have another question, as if I can use the manual ballooning workflows instead of the automated one. With respect to HMX, it's a very explicit definition. If we would, during the course of HMX, if we would tell it, if I go back to HMX here, no. And if I would come back here and say, hey, in my configuration, I can show or hide the balloons. I don't have the liberty to say I want to do them manually. Now, if I hide them, this is standard PTC drawing functionality in the background. You could absolutely document those things using manual techniques if that's a part of the company culture. There is no obligation to do the ballooning through the HMX workflow, but it does only give us two choices. We can hide them, in which case they aren't output, or we can output them, in which case HMX, you could, yes, HMX, yes, would otherwise create them automatically. To follow up to that question, if we hide them, does that mean we can manually create them? Absolutely. I could manually create them even if I didn't hide them. If I'm referencing a specific table or view, I might have to delete a pre-existing view or balloon to take ownership of that, because PTC would understand that the balloon has been deployed already in that view and on that, related to that table. But there's nothing different about the way the ballooning works from HMX to, the drawing than we would experience or expect on the conventional documentation side of harness manufacturing, or inside of documenting core Creo designs, PRTs and assemblies, if you will. The question, do we show, do we include or not the balloons, is the only part of it that HMX can take ownership of. If HMX does not output them, they would not be included on the drawing. If that information is culture or required for the company, then you would be obligated to go ahead and create them on the drawing, because they would not be there. Very good questions. Thank you very much for these questions. Can a wire schematic be added to the HMX format? I believe, and don't quote me on this, but I'm pretty sure through OLE or simple picture embedding, you can subsequently, whoops, I closed that drawing apparently. Hold on while I reopen that. Make sure this is the one here. I'll just get it from session. Oh, well, heck. I'm going to have to flatten it again. I must have erased not displayed. My apologies. Okay, so let's go ahead and flatten this out again real quick so I have that drawing to speak to. Okay, so here we've got it flattened out inside of HMX again. Now, when we speak to the idea of adding a schematic to this, the schematic is going to be created in a host of, exported in a host of different ways. If that schematic is an image or a PDF type thing or something, you would probably have to use some embedding, OLED embedding or something to that effect. If the schematic was exported as a DWG or a DXF from your schematics product, preferably Creo schematics, obviously, then you would simply bring that material into your, into your drawing as you would, like, importing a DWG, you could bring it into this drawing as another sheet, whatever the case may be in that context as far as that deal goes. But it would be dependent upon how you exported it, how that display and deployment on our HMX drawing, how you exported the stuff from schematics would be relevant to how that comes to bear inside of this drawing. Very good question. With respect to your assembly on screen, what happens if you replace the red cable with a new one? Or the red cable with a new one, would the assembly schematic lose reference? Okay, very good question. Now, I'm going to kind of minimize this guy off here, and we'll go back to, whoops, I had it. We'll go back to our cabling assembly. So if I were to make changes to this routing in some way, okay, the idea of HMX is, because it happens in, about 15 seconds, you just go create it again. You create a drawing from HMX that's current with your cabling iteration. Many clients want it this way because they want to do family table, or not family table, configuration-based deployments. So what that means is I might have a family table configuring my cabling assembly, and I open up family table instance 1, 2, 3, and then I HMX that, and that's the documentation for 1, 2, 3. Now I open family table instance of cabling ABC, and I say HMX that, and now I have the documentation for the ABC iteration of that configuration, for lack of a better description. HMX is designed and intended to work that way. Now, when we speak to the schematic losing reference, that's kind of outside the scope of this webinar, but just to speak to that in a mechanical sense, Creo Schematics creates an XML file, which is imported into Creo Cabling, and subsequently Creo Cabling then looks at that as a to-do list, and it is up to the user to perform that to-do list. However, that is exclusive to the concept of documenting anything with HMX. HMX will document what is currently regenerated on the screen. If you've made changes to your cabling assembly and you do an HMX document on that, away we go. That will be documented with those changes. So hopefully that kind of speaks to the distinction about how HMX is configured to benefit clients to put out iterations and options of harnesses in these configurations quite quickly and easily, as opposed to the more conventional mechanical sense, where if we utilize Creo, the standard documentation functionality that I began this demonstration with, okay, if we use that type of workflow and we make changes to this assembly, it is parametric to all that stuff, and it updates. So it can cause conflict for people to put out options of harnesses because they just want to be able to reconfigure this assembly, be it the cabling or top level, and then say make a drawing of that. When you use the more conventional techniques, it does become more cumbersome to create the iterations for the documentation as opposed to utilizing the HMX functionality. So hopefully that kind of helps speak to some of that context about how change is pushed through, where change is associative, where change is not associative, and where it happens and how it's utilized from both the schematic and the cabling sense. My example is wires only. HMX has no issues flattening cables, bundles, or transitions. Some of the above. When we start talking about cables and bundles, yes, no drama. When we talk about transitions, now you have crossed over into that. If you were present for the webinar where I spoke to, there are a few subtle changes about how you might document, or excuse me, not how you might document, but how you might design transitions and loops, if you will, inside of harnesses. There are some subtle differences that you might need to use to kind of make HMX be a little bit more dependable about flattening. There are only a couple of these, and if you give me a second here, I got a ton of windows on my other screen because of GoToMeeting, but please bear with me, folks, and I will go dig up this information and put it on the screen for you if I can source it quickly here. Pretty sure I have it somewhere. I can find it. Had a documentation sheet that spoke to that, and I apologize, I'm looking for it right now, but I'm not coming up with it quickly for exactly what is required in those changes. So give me a second. I'm going to keep looking. Bear with me. Hopefully I can source this, because it'll make this question very, very painless. It'll speak to it very cleanly. I cannot find. I will continue to look as I put my contact information back up on the screen here. And this is frustrating. My apologies. I just had this document not days ago. Finally, my apologies. Now we have it. Okay, bear with me here. I will get our document. Sometimes it takes me a long time to find stuff in the midst of all of my digital stuff. So when you speak to transitions and things to that effect in the context of the question, I'm going out on a limb here a little bit and assuming that we might be speaking to things like what we're showing now. When you do these types of things, there are a couple of considerations like what you see here. Simple loops, as we show, would change a little bit. Like you see here, it's fundamental, it's the same design, it's just how you're doing your location points or transitions, if you will, inside of the cabling application. And then when we have higher order loops, we have something along these lines in terms of how you might make some subtle changes to get the most of HMX. So my apologies for the delay in getting that information on the screen. I have like seemingly a billion documents at this stage in my career, and it's getting increasingly difficult for me to find all of them at the times and places that I would like to have them. But this is the information I was looking to display to speak to the transitions question. Cables and bundles, non-issue. These transitions do have these considerations that I've just spoken to. Higher order loops, as you see here. Simple loops, as you see in this view. So hopefully that gives some context to that question in good spirit. Very good questions. Please keep these questions coming, folks. I am happy to speak to these things, and if I have your patience, I'll do my very best to dig up documentation I may have that would be helpful. Any questions? We got about 5–10 minutes here before we'll wrap up, so sneak those questions in if you got them, by all means. Okay, so can the cabling module work together with Creo mechanism? In so much as that, yes, they all share the same Creo ecosystem. I don't know that, like some of mechanism and some advanced mechanism concepts and theories can get into design automation. I do know that to some degree, cabling would obviously support that on the face of it. If I were to, have some type of mechanism or design automation functionality going on where something would change in this design, and, for instance, in just my simple example, the footprint of the enclosure would change, then obviously the lengths of those conductors are changing. Things are changing, and that would be captured, inside of this design assembly. So to my understanding, I don't think there's any on the face of it conflict with the mechanism design and cabling, other than to say I don't think what I would say, like wire properties mechanically in terms of strength are maybe not something that you can take advantage of readily inside of mechanism design in terms of like how much pull on this harness till it breaks and things to that effect, or along those lines. But if we have a design automation that's manipulating the position of objects in 3D in some way, or the mechanism is moving and that is subsequently moving something that a harness is attached to, Creo would be regenerating those harness lengths and all of that stuff as a part of that process, just like it would any other mechanical objects on the cabling side. Very good questions. Branch bundles to define transitions. Do you see any problem with that method? No. That's, as the system will flatten those just fine. The considerations that we have in terms of the modeling side are as I outlined in terms of how you're basically defining loops inside of the cabling application. The thing to keep in mind is simple is good. And in your technique of defining location points, to follow these two rules as it relates to your more simple loops and your higher order loops, those are the big design considerations that you need to make for HMX. Can an auxiliary view be created off the connector's face to define master key clocking? Absolutely. In the context of our drawing, any views, any type stuff you would want to create here, this is all available to you. All of the, the 3D design here, of this harness as it comes from the cabling application is all here. I could have other predefined simplified reps or otherwise to define those views or those orientations that I might want to base that aux view off of. But I can absolutely define an auxiliary view to define clocking implications. This is standard PTC drawing functionality. What HMX does is gets you to this point in the race automatically. Excuse me. So HMX automates this much of the process. What you continue to build on and do from here is totally up to the client and the culture, and everything that you have available to you in core Creo about the way documentation works and looks and functions is the same. I am inside of the core Creo drawing package now, the Creo parametric drawing package by another name, and there's absolutely none of its functionality has been crippled or restricted by the process of getting here with HMX. Everything that we would expect to typically be here is here. And it's obviously, you can continue documenting off on this as you see fit. Will the presentation be uploaded to the YouTube site? Absolutely. However, I cannot give you a timeline on that. It does take a little bit of time for the marketing group to collect the presentation. They review it and, make sure I didn't do anything silly and, get it packaged and, uploaded and taken care of to YouTube. But it will definitely be one of the many things that exists on the Boundary Systems YouTube channel, and I would not expect that process to take a terribly long time, but I would say it might be a stretch to expect it to be there today or tomorrow. Maybe next week or the following week is probably practical, but I don't know that that's something they get done in 48 hours. They may very well do that. I don't work in that group, so I don't know, what their current, demand and stuff is, and, I can't really speak to that. But the explicit yes, no, will it be on YouTube? Absolutely, and it's not going to be a terribly long time before it is. Very good questions. I am very thankful for all of these people, or all of you folks punching in these questions to me in this. And we have just a few more minutes to take a last call here on questions. For the folks that remain, again, I'm very thankful. This is the part of the presentations or the webinars, if you will, that I always enjoy the most. And again, many thanks to everybody that's been providing questions and doing so, because it's very good for not only my opportunity to share to you, but it always inevitably benefits others in the presentation as well. We'll be wrapping up right around 12:30 Eastern time here, coming up on that. So again, last calls for questions from our participants. Don't hesitate to sneak those in, and we'll get a chance to speak to them. If I run over a little bit, speaking to your question, that's fine. If we don't collect any more questions between now and 12:30, we will be wrapping up our webinar at that time. Excellent. We have a last call question. So how easy is it to add, remove, modify the cable entry port? When we speak to the cable entry port as it's viewed by HMX or by the standard documentation theory, if you will, When we speak to the cable entry ports, these things are defined as part of our cabling parameters here. So when we look at this particular connector, I'm pulling up the lamp con cable parameters for this now. We see that the lamp con, well, let me go to my entry ports here. My lamp con has entry ports defined, and we have LP1 and we have LP2. Now, when we go into the lamp con and we expand it, we see here that we have a couple of coordinate systems, LP1 and LP2. These are the definition of our entry port. If I were to redefine this entry port to be in a different location on the connector rather than where we see it deployed here, right at the little pin example, if you will, if I were to move that in some way, this conductor that is attached to it would automatically come along right with it. Modifying that could come in a host of different ways. I could come to this interface and say, hey, I want to use this P coordinate system or the default coordinate system as one of my entry ports. I could mechanically, from a modeling standpoint, redefine one of these coordinate systems here at the lamp con model level in order to redefine that entry port. Any of those things would obviously be captured parametrically by the cabling package, and then you would have a redefined or modified entry port. If you were to remove one, the context of conductors that are routed to that would come into play. Now, if I were to come in and physically delete this coordinate system that is used explicitly for routing of this red, conductor 1, if you will, I would subsequently get a broken wire definition here on, well, I didn't pick the right one, it's W3. So I would get a broken wire, information feedback here on my W3 because it would not have a complete routing from end to end. The endpoint would be missing at that point, and it would subsequently break that wire inside the harness and then subsequently, require you to do rerouting on that. HMX would not, as I understand it, output that wire to a flattening state because it doesn't understand where it starts and stops. It doesn't, the termination definition is now absent. So hopefully that speaks to, the mechanics of modifying entry ports and their implications as it relates to not only cabling and its routing, but then by extension, those implications as it relates to HMX and, conventional stuff. That would also, the example of removing that coordinate system definition for our entry port would also break this wire for the purpose of conventional. As I started, conventional documentation where we use the harness manufacturing file inside of Creo as opposed to using HMX. It would be broken in both cases if the entry port became missing. And, subsequently documentation would break down for that because, we deleted a reference. That's no different here than it would be in the context of deleting something that we hang a dimension on in core Creo. Depending upon how your configuration is set up, the dimension is either automatically removed or the dimension is displayed as out of date and essentially locked until it's reattached to something. So very good question. Very good question to get in there for our last question for our session. I appreciate immensely all the questions that participants gave us today. It makes a much better webinar for everybody to get some engagements from folks in the question and answer space. I am thankful for everybody's time and attention and participation today. I would again encourage folks to not hesitate to look this up on the Boundary Systems YouTube channel. Again, marketing folks may not have it up there yet today. We got to cut those folks a little bit of slack at least, but it will be up there soon. And don't hesitate to go review this process again on the YouTube channel. And by all means, either reach out to myself or our sales team with questions or licensing or purchasing inquiries or technical inquiries to myself about all things HMX or Creo and cabling and stuff and all those types of things that we talked about today. Again, thank everybody immensely for their participation. It's been a pleasure to deliver this webinar to everybody today, and I look forward to hopefully having you folks participate in our future webinars with boundary systems. And with that, I will close up our webinar and wish everyone a great day. Again, thank you very much.